Hi, and we're welcoming back to Hope 2020 at our conference now. We're going to have a session with OSINT Facilities by Physical Reconnaissance with Bill Croydon of GGR Security. Hi, Bill. How's everything going? So we're going to go right to the movie right now. Thank you, and stay tuned.
Hello everyone, I'm going to be talking to you about open source intelligence of physical facilities by physical reconnaissance. So walking around, looking at the outside of the facility, but not ever actually going in until the very end. So how much we can tell just by looking at the outside, what is inside of a facility. To start off, we'll introduce some very basic intelligence doctrine. This is what's known as the intelligence cycle that you see on your screen here. And we start out with the entire world. We identify what our needs are, which produces our operational environment, from which we collect data, process it into information, and then analyze it into intelligence. Once we have this intelligence, sometimes it identifies something else that we need, and the cycle starts over, and it ends when we take action based on that. There's a number of different disciplines within collection in terms of where this data actually comes from. The ones we'll be focusing on today is imagery, so taking pictures, which traditionally means satellite, tactical imagery, or imagery intelligence, or IMINT, which is reconnaissance that we'll be talking about a lot, and public sources, so open source intelligence. Open source intelligence is sort of a buzzword in the hacker community, so that's why I'm focusing on that in the talk title here. And I'll just make a quick note as well that reconnaissance in American circles is often shortened to the word recon. In Canada, where I'm from, we use recce. So if I say the word recce, that is what I mean. The bulk of this talk is going to focus on the analysis phase. So taking these images that we've got from these various sources and turning them into something usable for an operation within the facility. So before we actually get into the analysis, we need to talk about collection just a little bit. And first, before we look at the facility itself, we're going to look at the neighborhood of this facility, both physical and political. So the area, what is nearby, utilities into the facility, nearby shops, transportation infrastructure, etc., as well as politically, if that organization has other facilities, what are they like? And that'll give us an indication of what we'll find within the facility. Finally, it's important to observe at different times, so day, night, weekend, and most importantly, normal operation and during an anomaly, so we can get a sense of what's actually normal. We also want to recce the people, see who enters, and generally what type of person they are, what they're wearing, when they enter and leave, and we can actually, if we're very diligent, keep track of the numbers and get a sense of occupation within the facility at any given time, what entrances and exits are used, and where they go when off-site. And then on the security side, we can look at the individuals for if they have keys or badges. We might be able to photograph or clone those. If they do some sort of security task entering, like putting in a code or signing in. And if we see site security, we can see what they do during an incident, and if it's in scope, potentially trigger an alarm ourselves. So in scope here, meaning that the client has actually authorized us to do that on a penetration test. What we'll be talking about for the bulk of this talk, though, is what's inside the facility itself. And we'll be looking fairly heavily at floor plans to do that, which are generally, we can kind of categorize them as assignable space, so that'll be offices and other usable spaces, circulation, so hallways and stairs, as well as building support space, like mechanical rooms, elevator, or not elevators, sorry, washrooms, custodial, etc. What are floor plans useful for? Well, we can take them and get a general topology of the space, which will give us the best path to get from A to B. We can take that and determine the time to get from A to B, which is very important for planning both red team operations and blue team defenses. We can look at what camera placements are possible, what camera placements we know might exist, what's visible from where. We can analyze the acoustics likewise and tell what can be heard, where can I be heard, where can I hear other people, and how much noise can I get away with making. And finally, if we plan to social engineer our way into this facility, it really helps to know where we're going. So sometimes you can get these floor plans from the fire safety plan box. These are often easy to bypass non-destructively, and they're almost always destructively enterable because they're designed to be for the fire department. We can also often get floor plans online, by using a number of different search keywords that work well. So look for PDFs, or how most floor plans are, and on the site that is interesting to us, as well as a couple other good keywords that are very frequently found on floor plan files. When we're inferring floor plans, so if we don't have that, um, then we're not going to get a very high level of accuracy, but we will get something that's topologically good enough for whatever operation we have planned. To actually perform that inference, we're going to start with what architects call massing. So that is the mass in three-dimensional space, the shape of that building. And that's comprised of both primary masses, so the large shape, as well as anything smaller sticking out of it is a secondary mass. The building envelope is another term that envelops the massing, and it's the surface area, so to speak, on it. It contains doors and windows, and we'll use throughout this presentation the architectural term for windows, which is fenestration. It might have mechanical equipment like vents and louvres, as well as external structural members. All of these things are clues to the internal layout, which we will talk about in depth. Where to get this imagery and massing, we can look at Google Maps, which for some cities has a really wonderful 3D view. Google Street View as well to get the street level imagery. Bing Maps I actually find to be very, very good for satellite views. Your local government open data will often publish aerial photos, including historical ones, and 3D massing data in computer readable formats that contain very, very useful information and measurements. And of course, visiting in person, taking pictures, observing, so that's your tactical imagery intelligence there. Beyond the massing, to determine what's inside of a building, the usage is incredibly important. So if it's an industrial building, commercial, institutional, multi-unit residential, and high-rise office, all of these have different usages which we'll look at throughout this presentation. And the layout depends on that and the massing. So warehouses, for instance, tend to be large and flat, of course. And most of the inside is large open space, but of course there will be racking within the warehouses. How is that racking arranged? Well, it's hard to tell, but you can look for the loading dock. And from that loading dock, you can infer that the main aisle will come out from it. It'll give you some sense. There's also often an office space on one side of the warehouse, and you can tell where that is by the fenestration. For commercial facilities, so storefronts, the frontage is what's valuable there. So they tend to be very long and deep without a large frontage. And within them, that floor plane is now very linearly constrained. And we tend to see usually a single barrier between the front where customers go and the back. For larger retail spaces, you see that as well. Because the back tends to be like a warehouse, so it's an open floor plan, and the front as well to encourage customer circulation. For institutional buildings, we'll start by looking at hospitals. This is a very, very typical turn-of-the-century hospital architecture. We can look at the fenestration, and it indicates the room size quantization. So most of these will be individual patient treatment rooms, but some of them might be 2 or 3 windows, but it gives us that quantization, so how large incrementally they can be. And so most rooms do have windows in older architecture because heating, ventilation, and air conditioning, or HVAC, was in its infancy at the time. And so this will make the circulation and room plan readily inferable. So in this particular case, if we look at the massing, we can see it's very long, very thin, with a number of branching wings to give everybody a window. But with this, we can tell quite well where that hallway is going to be in the middle, with rooms on the side that follow the quantization of those windows, and throughout the overall space of this large facility, that holds true as well. Where within this mass are the hallways? Well, usually we can assume it's halfway in the middle, but sometimes fenestration or massing tells us. So we can see this hallway here, and that tells us exactly where the hall is in this particular wing. Here's one case where it's not in the middle, but this bridge will give us a sense that it's on the edge, so we can tell that from that piece of information. Prisons tend to be tend to be laid out in very long forms as well, within which we have the cell blocks. Once you've seen one, you've seen them all in terms of what these cell blocks look like as the inside floor plan of prisons. An interesting aside about that, in terms of prison escapes, you often hear of escapes involving tunneling out of your cell, etc. Well, every cell needs a toilet, and every toilet needs plumbing, and that plumbing, by its very function, must connect to somewhere external. And so many prisons, particularly old ones, have crawl spaces or even tunnels that the toilet plumbing goes directly out to. Um, this is a little bit more applicable for those of us who aren't trying to break out of a prison when identifying the washroom location in, um, in a building that we are wrecking. So washrooms also need plumbing, and in a multi-story building, that plumbing tends to be put in pipe riser shafts. And those pipe riser shafts tend to end in mechanical penthouses on the top of the building where there's various mechanical equipment using other pipes in that shaft. So in this case, we see this penthouse, and we can infer that the washrooms are very likely below it. For a monolithic institutional, so a much larger massing space, a newer building it tends to be, we can start to get a sense of what the internal floor plan is going to look like by identifying the entrances and exits. In this case, we can see this large glass atrium, and there's also an exit on this side here, so we can infer that all the way up, the building is split down the middle. Um, and we can then have effectively two small buildings that we now have to determine the internal massing for the internal floor plan for. Um, in the basement, however, it's going to be below the atrium. So how do we tell what's there for that? Well, we're going to identify where the stairwells are likely to be. So for instance, this jut element off to the side here is very likely a stairwell. It's too big to be an HVAC element that's been added on after the fact. It's not really the right dimension for an elevator if you compare it to a car here. Most elevators aren't that shape, but it's perfectly dimensioned for a stairwell. So that's almost certainly what that is. They also tend to be below the entrances, of course, as well. And, and so we can get a sense of where the entrances to the basement level are going to be. Within that, we can generally identify a ring, some sort of equal distance from the edge of the building, and there's going to be a hallway following that ring pattern, and then appropriate hallways in the middle. And so we see that in this particular case. It's a somewhat T-shaped building in the basement, and we have a T-shaped ring with a hallway in the middle where it makes sense, and here's one going out to that stairwell that we identified. In this particular case, we have a T-shaped mass, and so we can infer that very likely there's going to be a T-shaped hallway on the inside. Also notice that these tall windows in the front here, that indicates that there's going to be some larger common area occupying these rooms on each floor. If we look at the floor plan for this site, the first thing we'll notice is that we were actually wrong about the hallways. There are two of them along each wing of the T, and we could have inferred that if we did a bit more research and determined that this site is actually a long-term care home. So based on the typical room sizes there, we could see that that ring-shaped floor plan following the outer perimeter is more likely what we're going to see with hallways in the middle where it makes sense. And then this dining room is exactly what we expected to find, given those large windows there. Here's an interesting case where we have 45-degree angles that would be visible in the exterior massing, which generally means that we have two different orientations of halls and rooms on the inside. Where do they actually make that transition? Well, we can tell based on circulation requirements. So in this case here, this green boundary, so to speak, between the 90 and the 45-degree angles, it can't really continue on over here because it hugely interrupts circulation. So we can infer that very likely this hallway is in fact where we can see it is on the map just by looking at the outside of this facility. Also to note, we have three different wings here, and we can tell where this large hallway is in this middle wing here because of where it connects to the other wing. And so that gives us this larger hallway, and then these smaller ones in the remainder of this monolithic wing follow this ring pattern a certain distance from the perimeter. Let's talk a little bit about high-rises. There's a lot of things that are often stacked in high-rises. So elevators obviously do, structural columns and stairwells. Washrooms, as I mentioned, they have that pipe space behind the toilets. In this case, the pipe space is right here. Telecom closets, electrical closets, all of these different risers tend to be vertically stacked, as well as mechanical rooms and vents to allow for easy flow up and down the building. What that generally translates to in newer high-rise construction is a central core that contains all of these elements, so your elevators, stairwells, washrooms, mechanical rooms. And for office buildings, most new construction is built as an open um, layout around that, which then the tenants can partition as they see fit. High-rises also tend to have entire floors dedicated to mechanical equipment. So often there's going to be one or more mechanical penthouses in high-rises. You can see one on this building to the rear here. The fenestration only extends so far up that above that to the roof is likely a mechanical penthouse. And low-rises would have that HVAC bare on the roof, which we'll look at later. Mechanical floors can exist partially up the building as well, so this tells us that there's not generally going to be occupiable space on this floor. And many buildings have mechanical basements as well. In terms of those mechanical penthouses, now that you know what they are, you'll start seeing them everywhere. Anywhere the fenestration doesn't go all the way up, you can infer that's what's happening. They're also often very cleverly integrated into the architecture, so this triangular element here, and these windows that are not fenestration glass going up to the top of each of these buildings. In terms of what high-rise residential floor plans tend to look like, they're going to be a central core as well with your stairwell, elevator, and building support systems, and often a ring-shaped corridor tightly surrounding that, or sometimes a U-shape that gives access to each of the units in that building. For older buildings, where we can't infer that the stairwell is likely at the core, how do we tell where that's going to be? Well, in older buildings, the stairwells do tend to be on the outside of the building. Part of that is for fire egress reasons, and so you also see doors at the bottom of many stairwells. We can also look and see that we have lit stairwells and unlit windows around it. So if you see a lit up column of windows all the way up, it's a very good indication that that is a stairwell. And of course, in these cases, you can actually see the stairwell in the windows as well. That helps. So in this particular case, we can see a very, very well lit up column of windows, so that's likely a stairwell. The building's likely symmetrical, so there's probably one on the other side. To get a better sense of the internal layout, we can note that there's 2 balconies on each side with a partition, so likely 4 units per side or 8 on each floor. And the elevator is likely, of course, in the center. We can see this mechanical penthouse in the center as well, which would house that elevator equipment. So in this case, where is the stairwell? Well, we can see dark, 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 but a lit up column of windows, and you can even see the stairwell within it. In this particular case, we see 2 lit up columns of windows. It's unlikely to have 2 stairwells that close together, and in fact, one we can see through the windows is a hallway, the other is a stairwell. We can see that that hallway extends deep into the building, and we can see washroom signs on each floor out of that hallway, so it makes sense that those are stacked. And between the external building massing and that hall direction, we now have a very good idea of the total internal layout of this building. We can also look at fenestration to identify stairwells even in the daytime. So if we see windows all aligned at a particular floor height, but then one part of the building where the windows are at half floor heights, that's a very good indication that that's landings from a stairwell in that location. In this particular case here, we see windows zigzagging all the way up, which tells us that it's likely a staircase zigzagging all the way up along that. We can also see this secondary mass sticking out of the building here that houses just that stairwell. When the stairwell is normal to the building envelope, so it's extending perpendicularly inwards, we see here this half-height window. As well, you might also see a column of glazing unbroken all the way up, and that's only really possible in a stairwell normal to the building envelope. When you see a fire escape, of course, that's a good indication that there's no stairwell there. Not a whole lot else you can infer from these because they are retrofits. If we have multiple doors, so I mentioned that a door at the bottom of a building is a good indication that there might be a staircase on that column of windows above it. If there's multiple, we can identify which one is likely the primary exit from the building by looking at safety features. So safety lighting up here, as well as this is a parking lot, and we have vehicle bollards to protect against vehicles ramming into someone exiting this primary exit. This is a very good indication that there's a staircase or at least a hallway behind this door. These two are likely mechanical spaces, and in fact, they are a transformer room. We can tell by these decals here, as well as this vent louvre there. So here's a good test. Is this building likely office or residential? Well, looking at it, we see that all the windows are lit on the bottom and none of them are on the upper half. That's very atypical for a residential setting. So this is likely an office building. It's clearly a newer construction that was built incorporating an older facade or older structure. And so because of that, the stairwell, there might be staircases on the outside of the older structure, but we don't see any lit columns of windows in this newer structure. Because of the fire code, there have to be emergency lighting there, so we can infer that they are on the inside, and this being an office building, it's likely an open layout that might be partitioned by the tenants. We can spot elevators within the building, as well as potentially more stairwells, by looking at the roof of a building that does not have a mechanical penthouse. So we have three secondary masses coming out of that roof. This one in the center makes sense to be an elevator machine penthouse, and the sizing makes sense for that as well. If we compare to these vehicles down here, this is likely the top of two staircases opening up. This would not fit an elevator there. And it also makes sense in the context of the main entrance to the building down here. So we can infer that the floor plan here is going to be an S shape terminating in two staircases and with an elevator lobby in the middle, and on the ground floor, an exit out the front, likely an exit out the back as well, and units surrounding it. In this case, we see on the left an elevator penthouse. The fenestration goes right to the top, so we can tell that there's no mechanical penthouse, so the elevator must be here if the building has an elevator, unless it's a hydraulic, but that's unlikely for a building of this height. And in this case, we can see the elevator, freight elevator opening right out the back. In the case of an attic, we can get a sense of whether it's occupied, mechanical, or dead space by looking for both skylights on the roof as well as windows in the gable, so this flat section on the edge of the attic. And we can also potentially do thermal imaging to tell if it might be occupied at room temperature, at outside ambient temperature, or if it's very hot, it's probably a grow op. Utilities are also very, very useful for determining the internal layout. So we can locate them by looking for cues like this fire standpipe here, as well as seeing a mechanical room through the window. In this particular case, can we spot the mech rooms? Well, we notice there's a fire standpipe there. We can see pipes in this window, and these two louvres here. So there's likely a large mechanical room there. On this second floor, we can see this continuous fenestration, and we can see everything within it. Also note that the walls are actually visible, so we can start building up the internal layout of that second floor. But we can see there's no mechanical room there. On the third floor, we have this louvre and a large area without windows. So that is likely a mechanical room as well. Given these two, there's almost certainly a riser shaft of some sort connecting these recessed into the building. We know it's not on the edge, of course, because of this fenestration. We can estimate occupancy of the building using utilities as well. Sometimes it's just given to us, like with a Enterphone directory, but sometimes we can look at utility capacity. So in this case, on this building, we see a telephone line coming out of an underground conduit. This is likely a 50-pair line from the radius of it. And so this picture here is of a 25-pair telephone line, which supports 25 separate lines within the building. And so we can tell that when this was being planned for by the telecom company, they usually conservatively guess that, well, the absolute maximum we'd ever see in here would be 50 phone lines. It gives you a sense of the occupancy. There are loads of other utilities that buildings require. ones that are internal to the building entirely, ones that come from an upstream source, and ones that are entirely external. And looking at the incoming utilities for other things, we can also tell. So for HVAC, that's heating, ventilation, and air conditioning. In this case, all of our air conditioner units are visible on the outside, and we can look up the capacity of those to get a sense of what the occupancy inside the building is. If you ever see a large uh, box like this on the roof of a building, this is a cooling tower. And those boxes before I erroneously called air conditioners, they're actually just the cooling tower as well. Um, this will feed a chiller that looks like this and is usually going to be in the mechanical penthouse below it. And by the capacity of these cooling towers, you can estimate what the cooling requirements for that building are, which gives a sense of occupancy and activity level. We can also spot the incoming transformer room. So this is a grade level transformer vault. It has the power company's locks on it, as well as decals. We might have a pad mounted transformer exposed to the elements outside, and we can read directly off of that what make it is and what its capacity is. And we also might see these below ground transformer vaults here. They universally look like this. So now that you've seen this talk, you're going to start seeing these everywhere. Based on the size of a 1 or a 2 transformer vault, we can get a sense of what the capacity is going to be. And based on the position, we can get a sense of where the building's mechanical room will be. So this is a fun picture of how they actually maintain the transformers here. They're going to crane lift off these concrete slabs and crane lift in a new one. And on the inside of them, we have power coming from upstream in these conduits, which then gets sent to a conduit to the customer building. So again, by placement of these transformer vaults, we can get a sense of where the electrical room in the building is. And of course, we have overhead lines as well, and they're going to come from the power poles to pipes or conduits along the building, and we can get a sense of where within the building their electrical room is as well from that. Buildings might have standby generators as well. They look like this. We can't usually see them from the outside, but what we can observe is the diesel refueling stations, which look something like this. This indicates that it has a standby generator within it, as well as where it likely is. And so that'll give us a sense of what the general criticality level is of this particular building. We can also observe the water shutoffs to get a sense of where the incoming water mechanical mech room is going to be, as well as gas shutoffs and meters. We can look for sewer cleanouts to get a sense of where the sewage runs out of the building. And we can also look for security features that were deliberately engineered into the building to get a sense of what's inside of it. So in this particular case, the two most salient items are this very bright glare lighting here, as well as vehicle protective bollards. So these bollards are to protect against vehicle impact attacks, as well as truck-mounted bombs. Any building that has that in its threat model is likely something fairly serious. Like in this case, an American flag in Toronto is likely a consulate, which it is. So that was public knowledge anyway, of course. But for obvious reasons, I can't give you an example that is not public knowledge. And as an extra bonus, we have these half-height windows here indicating a stairwell. So let's look at a few case studies. We have here a event space. Its first floor is commercial tenants, we can tell by looking at it, and it was built in the 1850s. So to determine where the main event space is going to be, we can look at the fenestration and the massing. We can see from this fenestration that there's likely not any large event spaces in the wings or in the lower half of this central mass, but in the upper half we have this artificially elevated aspect here, so the event space is likely in the middle. Where are the stairwells within this? Well, there's likely one as well as an elevator coming in from the main entrance, as well as, because this is a very old construction building, the stairwells are likely on the exterior of the building. If we looked at this at night, we wouldn't see any lit columns, which indicates that the stairwells are likely not fenestrated. So here's a large area unfenestrated with an egress door at the bottom. That's likely a stairwell, and as it turns out, it is. And looking at this floor plan, we can also see the space below the event space wide open here, as well as the commercial areas to the side, which are not even connected on the ground floor, and of course the main public entrance at the base leading to the main stairwell and an elevator. This is a really, really great case study. There's a lot we can tell from this particular set of pictures. So looking at this building, the first thing we'll observe is this large chimney stack here, which indicates that the furnace is somewhere below it. The furnace could be in a mechanical penthouse, but we see that there are none on this building by the fenestration. It could be below ground. In buildings like this, you tend not to see complete basements, but we also notice this break in the windows here. So this is likely where the boiler room is. It's interesting to note that it's 2 stories because most boilers are taller than the average floor. So if they're interstitial in the building, they'll likely be 2 stories spanning. If they're in a penthouse, that's part of the reason why mechanical penthouses are taller than most occupiable floors. And if they're in a basement, they're likely downstairs from the regular basement level. We can also note this penthouse over here. And looking at the aerial view, we can see that there's nothing else that could be an elevator penthouse. So if there's an elevator in the building, it is either here or a hydraulic elevator. And in general, all of this HVAC and mechanical equipment around it indicates that this is where the central core of the building is, supporting most of the mechanical space. Um, very, very interesting to note as well are this structure here. So this used to hold some sort of HVAC, heavy HVAC equipment. We don't know what, but we do know that it is supported right above the structural columns of this building. And it's not visible in the pictures here, but those structural columns actually line up with the breaks in the fenestration. So from that, we can infer that there's 4 columns here, that they are likely matching up with the breaks in the fenestration along the building, which makes sense, and columns tend to be in a consistent grid throughout. So we can deduce the entire structural diagram of this building by these 2 pictures. We can notice a main entrance in the bottom left, so we can infer a hallway here leading to the elevator. And in terms of the use of this building, this is a very typical layout that you might see of a multi-tenant medical building. Based on this fenestration, though, that's unlikely to be the case, since this is not consistent with patient rooms. So if it is a medical building, it was a retrofit for that purpose. The washrooms are likely going to be in the central core as well, along with all of the other mechanical equipment. And so all of that put together, we can get a very good sense of what this building is going to look like on the inside. Of course, we don't know much about what's in the wings, but if it's rentable office spaces, most likely, it's probably going to be an open floor plan with the columns in the middle. We know where those are. That'll be partitioned by the tenants, and those partitions very often follow the column grid. If we have an irregularly shaped building, how do we tell what's inside of that? Well, in this case, the building's triangular, and we kind of have 2 options. This is a residential unit, a residential building. It might be a linear, linear hallway throughout the building, or it might be triangular, using that ring inside the perimeter of the building that I mentioned before. And as it turns out, that's exactly what it is. As expected, we see in the central core of the building staircases, building service, and elevators. So that was a lot about how to tell what the floor plan is of a building just looking at the outside. What do we do when we actually enter? So we want to always maintain situational awareness. This is true for red teamers as well as first responders, which a lot of this information is applicable to, as well as blue teamers like security guards that might be going in to protect the facility. And they could be facing a real threat. So you want to look for corrections to your inferred internal floor plan. Any room you enter, you want to identify all the exits to it in case you need to exit quickly. Identify the windows, potential hiding places that either you could use or someone could be hiding, waiting for you, as well as items that could be used as weapons and the various life safety and security equipment that might be present within that particular room. You also want to be situationally aware about individuals and crowds that you encounter. So with crowds, you want to look for the destination and the rate of flow, the average inebriation level of that crowd, as well as try to identify persons that are not fitting in with the crowd normally. So an armed person, you can identify them by security paths. So if you are ever wondering, oh crap, did I forget my phone or my wallet at home? going to pat your pocket and see, okay, it's there. That's true as well for an armed person, especially one that's planning to do something with his concealed weapon. So if you see someone repeatedly patting where a hip or a shoulder holster might be, that's a very bad sign, and you should watch that person. Plainclothes security as well, they're going to have that level of vigilance, and they're going to be watching the crowd in an abnormal way. You can pick that out very easily, and you can also get a sense for each person what their likely familiarity with the area is. So I've talked a lot about protection. I've talked a lot about not protection, the opposite, about the red team's needs. That's what I focused on. There's a little bit that we can talk about for protection as well. So the blue team, what they can do, your floor plan is difficult to obscure. What you can obscure, though, is your high-value targets within the floor plan. You should assume, though, perfect knowledge by the red team of both your layout and the location of your high-value targets, and that is what you should be protecting against. Based on the information that would be available to a red team or to a real threat, you can anticipate their actions based on what they might do with that information, and you can also set up your facility to canalize their actions, to force them to take a single path that you can then more heavily protect. You want to duplicate critical assets as well, and your overall goal as a blue teamer protecting against these techniques is to turn their open source and imagery intelligence into mere information that might be interesting, but it will be ultimately irrelevant to their goal of an attack against you. So a couple of takeaways that I'm hoping everyone will get from this talk is generally be more situationally aware in your everyday life. So I imagine most of you likely don't make any of those observations when in a crowd, in a room, or looking at the outside of a building. Now you're able to. Hopefully this will let you look at built infrastructure a little bit differently, and when you enter a new and unfamiliar space, hopefully this will give you a sense or the ability to actually know where you're going, even though you've never set foot in that space before. I'd like to extend a huge thank you to Karen, Bobby, Josh, and Eric, some of my amazing coworkers, for their immense assistance in putting this talk together. And if anyone has any questions, if you're watching this later on YouTube, I'd encourage you to reach out to me. I'd be happy to answer any questions you have later. And for those that are watching the live stream right now as HOPE attendees, I'm happy to answer your questions right now. So with that, thank you very much, folks, and I will turn it over to our lovely MC.
Hello, and welcome back to our talk with Bill Graydon of GGR Securities, who just presented an incredible discussion about open source intelligence by physical reconnaissance. Thank you, Bill. That was really a great show.
Yeah.
So, is there anything else that you'd like to add to the video before we start taking questions?
So I guess one small thing that I realized after the fact that I'd forgotten to properly explain was the significance of elevator penthouses in terms of hydraulic versus traction elevators. So there's those two main types. Hydraulic elevators are driven by a big ram in the bottom, and their penthouse, well, it's not a penthouse, their machine room is in the basement usually. But because that ram has to extend an equal distance into the ground, you don't see that in high rises at all. They tend to be lower 2 or 3 story elevators, and as well very old buildings. That technology didn't exist. Every other elevator needs mechanical penthouse above it, with the exception of some very modern ones that generally are terrible. But that way you can tell if there's no mechanical penthouse expanding on the entire building's floor plan. You can tell where the elevators are by seeing that stick out. So I thought that deserved a little bit of an added explanation. Other than that, though, I'm good to start fielding questions.
Great, thank you. We'll get right into it. Our first question is, are there recommendations for methods to fake external building layout with fake external egress and elevator/roof layout/access? I was thinking about Hotel Penn would be entertaining.
That's a great question.
So the answer is there are methods, and it's, I could probably go on for hours about different case studies and ways that you might do it. It is highly case specific. So the best way is to, you can obscure some things. So omit windows where they might otherwise be, and without that fenestration cue, there's a lot less that can be determined. And then base the massing, say, to look like something else than what's actually inside of it. And so what you do is get people who are experts in reading buildings in the type of way that I've talked about. So firefighters and military tend to be very good at that. You get them to look at the plan and say, what do you think would be in here? And if they think it's something totally off, then you're doing a good job with that. In general, for non-military installations, like that's where you want to be focusing on sort of the deception element. For anything other than that, it's usually not a significant enough problem within your threat model to warrant such drastic changes. It's often easier to obscure what's actually inside the building. So for instance, with the HVAC exposed on the outside, that gives you a very good sense of what's going on inside. Enclosing your mechanical space, enclosing that HVAC in some sort of facade is a good way to obscure that. And as well, it gets a buy-in from the architect of the building, because usually the architects and the security engineers are really at each other's throats about that. So that's one way. But yeah, so obscuring for civilian buildings is usually best. As I mentioned, though, you're generally better off obscuring what you're actually protecting inside rather than the layout itself. And the last thing to consider is that there are life safety implications and trade-offs. So if you're obscuring an egress, obviously you cannot do that inside. People have to know how to exit. If you have what looks like false exits on the outside, that has implications as well, because if there is a fire call to your building, the firefighters are going to go potentially to the wrong exit, waiting for victims to come out or to force entry in. And so it could create a massive problem there. So there's a lot of things to consider, and usually this stuff is very interesting for physical red teamers to get information about the building, but it's not a big enough part of your threat model usually to warrant massive changes like that.
Got it. Thank you. Is there any public repository of building plans, like a kind of Wikipedia for buildings that people can contribute to anonymously?
Not that I know of. So in that slide I presented at the very beginning about actual online OSINT of Googling for those PDFs, generally you will find them on either the website of whatever organization owns the building. The closest thing to that public repository would actually be government tender websites. So any government contract has to go to a public tender, and that public tender includes all sorts of details about what it's going to entail, including architectural floor plans, usually a bunch related to that, like HVAC and structural plans as well. So those have it. Major construction firms often have those files up on there as well. Of course, that's not intended for that purpose, but it's a good place to find them. To my knowledge, there's nothing that's intended for that specific purpose. So maybe I'll make one. That could be a cool thing to do. So I guess keep tabs on my online activity, and I'll let you know if that ever comes to fruition.
Okay, thank you. The next question is any comment on movies that get physical security really right or hilariously wrong?
It's a great question. So I mean, I mentioned in the live chat that I could have talked about this, but I was constrained to a 45-minute video, and that would take days and days and days to go through all the things they get wrong there. I mean, not just physical security in terms of stuff like what I talked about, but I talked about, for instance, how you match the external envelope of a building to whatever's inside of it. That's something that, security considerations aside, most movies get wrong. Their external set and their internal set often have a lot of discrepancies if you know what to look for. So just about everything I talked about today in a movie does not apply at all. But there's loads of examples where physical security is, they might do something that's not really possible. The biggest thing that I see with movies that gives people the wrong impression of physical security is not necessarily that something is wrong or impossible, but it's just so far out of your threat model that if you're worrying about stuff that's cool enough to show into a movie, you're probably worrying about the wrong things.
Got it. All right, thank you. All right, we've got time for a couple more questions. The next question is, are there any sorts of buildings that are naturally hard to infer the floor plans of, even without any deliberate attempt at obfuscation?
That's a great question. I guess the two that best fits that description is, I talked a bit about monolithic buildings, which tend to be institutional or industrial. And so a monolithic institutional that has, your fenestration on the outside that gives you room quantization, and that's about it. But, if it's a giant 100 meter by 100 meter, by a couple of stories tall box with an enclosed mechanical penthouse at the top, you really have no idea what's going on inside of that box. And so, if it's got some architectural, landscaping and whatnot to obscure the incoming utilities on the inside, which wouldn't be intentionally usually for security purposes, that's just for making it look nice. It's very difficult to tell what's going on inside of there without doing a little bit more recce. So, you can look around, see which entrances people use, see when they enter, get a sense of what the function of that building is. And so then you're obscuring, or you're inferring that based on just the function effectively. The other type that is often very difficult to tell with is large industrial buildings, because now we have a very large mass in addition to very little fenestration. So in that case, it's entirely down to the usage. So you look at, well, what's actually being done in this industrial building. You look at similar buildings. You can usually get a very good sense from that, but not always, depending on what proprietary stuff might be going on at that company.
Got it. All right, thank you. And for our last question, are there external cooling elements for things like server rooms visibly different from cooling elements for occupancy?
The answer is in general, no. They're the same type of equipment. In particular, the things that are visible on the outside, such as the cooling towers, are all the same. Because that technology works with. The cooling towers are going to lower the temperature of your water glycol mixture to the limit of evaporative cooling. And then below that, you need to use chillers that tend not to be exposed or visible. So whatever temperature is the final ultimate temperature is hard to infer. What you can get some sense from, though, is the capacity. So for instance, data centers tend to be very obscured. They'll usually not have anything indicating what they are or the title of the company that owns them on their street sign, for instance. People like to not advertise where their millions of dollars of equipment data centers are. But you can look at the cooling capacity on the roof of it usually, or sometimes a mechanical space out the side. And if you can see that this building is getting cooled down with such extreme vigor that, whatever happens in there, it must be like this gym operating 24/7 with 1,000-person capacity. That doesn't make sense. So you can infer that it's probably a data center based on both the layout of the building and, of course, you can look at the incoming utilities. It'll be very well served by communications lines. Sorry, JP, you are muted.
There you go. All right. Thank you very much, Bill. That was Bill Graydon from GGR Security, providing us with his perspective on physical reconnaissance. Thank you on behalf of all the attendees and the volunteers and the staff. Thank you very much for sharing that with us.
Thank you.
Okay. And we're going to give you now to our regular bumps, and enjoy. We'll see you in just a few minutes.